So thanks for joining us and thanks for being with us since 4 o'clock. I think there was a lot of questions that was asked earlier on. I think just to set the stage for this one, I mean, we've called it the pivoting with agility and how it takes an ecosystem really. And it's from the point of view of Siemens, how as an MNC in Singapore and also with footprint around the world, how you've slowly transforming your journey, your manufacturing journey as well, also embracing advanced technology, advanced manufacturing, additive manufacturing, etc. So all of that is slowly coming together, not only in your hardware applications, but also your software that is integrating all of this together. So I think our audience definitely have a lot of questions to ask you, and I think we've spent a lot of time asking each other all of this. But yes. I want to give this opportunity for our group here. I think thanks once again to share your time with us. So do let us know. Raise your hand and we'll identify you, and we can turn on your mic and you can actually verbalize your question. And if you're a little bit shy, don't fret. You can always type your questions and we can read it out to either one of us. Okay, I do see there's a question from Aditi. She's asking, how can we better address the IP-related challenges for using 3D printing designs for medical products? So how can we better address, IP issues and challenges for use of 3D printed designs for medical products?
I guess like I mentioned slightly earlier, prior to as we jump off the call, the certification is probably one means to get through, where you certify the product. There's also a certification of the manufacturing process and also the actual manufacture of it. So certification will help in sort of ring fence quality issues, IP related topics. I think that is getting exceedingly harder to do because replication is so much easier. We don't have a good answer today. I think, like I said, certification is only part of the solution. How we actually ring fence IP with respect to medical devices, I think that's quite difficult. Within the 3D printing community, what we have done is do secure printing. So whenever we send a CAD file to a services bureau to do printing, we limit how many files he can print. So that limits the exposure on more products that he can replicate. It's limited and restricted to certain amounts, either using blockchain for tracking. So it's not an easy question to deal with, IP challenges.
Because it has definitely implications in terms of liabilities as well, isn't it? So, yeah. Pauline Wee, she's asking a question here, Ben. It's directed to you. Is there a range or a minimum cap in terms of investment to use the 3D printing techniques on industrial prototype designs?
So there are two ends of the spectrum. Yeah, one, you can have the low-end prototyping using polymer printers, the desktop FDM printers that we have today, using either SLA technology or FDM. Then you have the top end where the desktop printers can be as low as $100 to $200 US, up to $10,000 for a decent industrial desktop printer. Once you start moving into metal powders, it goes into the hundreds of thousands up to millions. And don't forget, when you go into the metal printing portion, there is a whole raft of post-processing equipment that you need: CNC machines, ovens, sandblasters, and cleaning. So there's a lot more as you go up the metal side of things. The polymer side can be cheap and cheery. I mean, materials now are getting stronger, the polymer side, and there's more industrial users of these industrial design using polymer 3D printers. So I would say you can go as low as 10,000, I would say, for polymer desktop printers for industrial use and prototype. But as you go into the metal realm, it will be, I would say, in the $500,000 and above sort of range.
There's a question. Yeah, sorry, go on.
And in my mind, what you invest in, it really depends on what your AM strategy is. Are you there for home-based sort of prototyping, or are you addressing an industrial need? Yeah, it's easy to print non-functional souvenirs using printers. But for us, when we focus on industrial prints, we want to print parts that are functional. So with every functional part that we print requires more certification, requires more quality checks, requires more simulation before we actually print, because the cost comes in the actual printing. So at Siemens, we have a lot of software simulations to kind of do the digital twin, to do the virtual commissioning before we even spend any money on material to print.
There is a question here to you, Ben. So how fast is the adoption of 3D printing by the industry? Well, obviously this has an impact on return of investment. So how fast is really the adoption?
And most of the industries today are very conservative, I must say. So marine is very conservative. Aerospace is very conservative. So every 3D printed part that it goes up in the aeroplane, 200 lives are at risk. Yeah. So I think the adoption is actually slow at the moment. They are trying to balance out the ROI. And I think addressing a previous question, whether it's scalable and whether it makes commercial sense really depends on your AM strategy. Like I said, we don't want to print like for like. Printing a like for like, the conventional versus AM will be definitely more expensive. The performance outweighs, the cost outweighs the performance in that sense. If you combine 5 components from one assembly to one individual part, then that's where the value comes out, and that's where the scalability and the ROI will be met a lot faster.
I think if you look at Singapore, for example, in the last 5 years, we have seen a steady uptake of adoption and awareness. I think has really come a long way since I got to myself involved in this business in 2013. So in the last 7-8 years, it's really come a long way. But I think to your question in terms of return of investments, of course, like what Ben was sharing, like what Siege earlier shared with us, if you're a small outfit, the few 3D printers specifically looking as a service bureau for a certain application, then you're going to have a better return of investment versus like Siemens, if you say, we're going to spend millions of dollars in equipment and how are we going to see the ROI for certain applications. So it's kind of, it's industry and also what kind of services you're looking at.
So one thing that we're doing here in Singapore is we're setting up the Advanced Manufacturing Transformation Center. And one of the aims is to accelerate the adoption of 3D printing or advanced manufacturing to really help customers bridge the gap from prototyping to industrial commercialization. And we want to help customers understand, how they can do it, help them build their AM strategy, tell them how to bridge that gap. We will have a full range of partners, OEM partners, 3D printers here at AMTC, and we will allow customers as members to come in and use the different technologies available. So they get used to it, they understand which technology suits their purpose, and before they actually invest in a whole factory worth of equipment and different technology. So we want to provide a low barriers to entry to test out all these expensive industrialized technologies, mostly on the metal side or even the polymer side. We're looking at industrial level sort of printing. We're not thinking of prototypes 1 or 2, we're talking about 100, 200 per print. So AMTC will provide customers that bridge the exposure to the right technology before putting in a huge capex investment to realize that this is not the right technology and everything has just gone to waste. Yeah, so we are setting up AMTC for that pure purpose of helping customers adopt and accelerate the adoption of 3D printing.
Yeah. So I think Meng is also very interested in finding out more about AMTC, and he's asking if it's a regional center or is it just purely for Singapore?
I think thanks to NAMIC, the decision has been Singapore. I think you guys have done a great job in building up the ecosystem. So if I look left, right, center, up and down, most of the key players are here in Singapore. Be it the services bureau, be it the R&D people, be it the designers, the software authorities, the certification bodies. The ecosystem is here, and we are based right smack bang in the middle of that. And we want to pull together this entire network to support the growth of adoption here in Singapore. Singapore is always focused on very advanced manufacturing because of the shortage of space. So we're moving not just into 3D printing, but also how the adoption of digital solutions will help make plants more efficient. In terms of regional, we're supporting the region because we feel that there's a cluster here that will help accelerate the growth. And it will be a beacon for people to come in, a lighthouse for people to come and see what's going on.
Yeah, there's a question on digital twinning. I mean, there's that this word it's like a buzzword that's being used. So they just want to know a little bit more about that in far as what's happening at AMTC in terms of digital twinning as well.
So specific digital twinning, you're asking?
Yeah.
So we have the NX suite of software. The digital twin does the digital virtual version of the product design. We have generative design that helps you come up with multiple permutations of a design using AI. So you don't have to think out of the box. It comes with the box. There is the digital twin of the process. We can actually design the process and how it goes and the tool path and the manufacturability. And we do the digital twin of the factory. So the entire end-to-end visual solution, you can put on Google glasses and the likes and walk into your virtual factory even before you lay any foundation and groundworks. So you will have an optimized factory that you virtually commission that accelerates the whole design process, the whole AM strategy that you want. Yeah, so the digital twin is a powerful tool where we can see the future before even embarking on it.
Yeah, I mean, that's really true. You need to ascertain before you want to embark on this journey. There's a question from Dina Ali. Which Singapore manufacturing sector sees more traction in adoption of AM in factories? So I don't know if it's particularly in factories, but I can also answer that, but go ahead, give it a shot.
I think we see the application of 3D printing less so on the actual product itself. We've seen it more applicable to the production line. So tools and jigs to support the manufacturing process. I think one difficulty that I've encountered in Singapore is a lot of these MNCs, that manufacturing plants doing advanced stuff, they are keen to explore AM. The center of excellence or the design hubs are not here. They don't make design decisions on their products here in Singapore. Singapore is purely a taker of designs. So currently the adoption more or less leans towards the jigs and supporting equipment to help with the production line. Until the adoption is stronger in say the US where the HQ is or the UK, then the designs will flow down and the manufacturing plant here just adopts a 3D design.
I think to add on to that, I think we see quite a lot of uptake in the MRO business for aerospace, marine and offshore, the maritime, oil and gas. These are actually seeing quite a lot of traction in terms of uptake. So that's leading the space, I would say. Of course, the healthcare sector also is quite close behind in terms of adoption. There is a question for you, Ben. What are the expected difficulties for an aerospace MRO to reverse engineer a legacy part or incorporate it into an assembly?
The technical difficulties will not be there. It's easy to do reverse engineering on the part. I think the difficulty is how to certify the part. Because you're not the main designer of that component, you don't know the technical requirements in terms of tensile strength. Is it in the x-axis? Is it in a y-axis? Is it following the column where the energy is transferred to? What are the tolerances required? It's difficult to know that without having the actual drawings from the OEM. Yeah, and I think that, like the biggest part of incorporating is not the technology. I think is who bears the risks and liability if something goes wrong, especially in aerospace. Yeah, so that's a difficult one. Unless you're the OEM or you're working with the OEM to push that down, trying to do reverse engineering yourself, it can be done, but the end user needs to take the risks when it gets installed or implemented on the actual equipment.
There's always a question of product liability insurance and so on, right? Yeah. So there's a question here from Meng. Is the adoption uptake higher for non-critical components or critical ones?
For sure, I think we see more non-critical components being AM 3D printed. for sure. I think that's the path of least resistance for a lot of OEMs and industries today. They want to show the adoption, and that's where you get baby steps for confidence, to build up the confidence within the industry. Because Siemens, we ourselves build our own gas turbines, and the gas turbines, aero gas turbines, are a replication of the jet engines that we see in the sky today. So we're trying to gain confidence on the ground gas turbines today in order to justify and give confidence to the OEMs that, you know, AM will be safe enough to go up into the sky.
Yeah, so yeah, that's true. I think non-critical components easier. It's not going to impact any lives and so on. Yeah. So I think there's a lot of effort goes into, you know, and care taken in terms of certifying and getting the standards right.
And I think from a commercial perspective, the non-critical one is not where the end game is, because the money and the margins are very thin. Yeah, so we are always looking at the critical parts, and that's where the margin for commercial viability is there. That's easier to justify. So I don't want to print a doorknob on an aeroplane. You know, why would one do that in 3D? You know, it doesn't make any sense other than gaining confidence to OEMs and the industry as a whole.
So anyone wants to turn on your mic and ask a question, so we can hear you as well. While there's a lot of good questions being typed in, but keep them coming. We're I think having a very good conversation here with Ben. A lot of good information. So while that's coming through, Ben, and just that, you know, I think what you've embarked on with the AMTC is really fantastic in terms of you know, seeding adoption and taking it to the next level for companies. I think everyone here who is listening in would be interested in engaging with you beyond today's session. So yeah, I think I'm sure they will. Is there anything that you want to share that you know, why they should come to the AMTC?
The three sort of foundation messages from guiding principles, I would say, for AMTC is simplification, digitalization, and collaboration. So we want to simplify the whole mythical industry through digitalization. We have a lot of digital tools that makes it simple for people to use and to do generative designs without having to squeeze your brains and brain power to construct a solution using 3D. And most importantly, it won't be a Siemens only solution. We're tapping on a whole ecosystem of partners. So we have a wealth of 3D printing companies, certification bodies, designers and consultants, material manufacturers, and the different platforms for the 7 different technologies for 3D printing. We not only look for customers that come in to adopt, we're also looking for more industrial partners in this ecosystem to kind of showcase on industrialized platform. We want to show customers and companies how to industrialize and do a 3D manufacturing line. We want to bring OEMs and partners and help them onboard their equipment onto our infrastructure so that it will be a plug and play system, making it easier for future companies to adopt your technology as a whole. So we see ourselves as an integrator. We want to do the multiplier effect, as I mentioned many times before. We want to encourage the economy to go that way, the industry to go that way, to pick up Industry 4 techniques. And it's a journey, this transformation. It doesn't have to happen overnight. You have to understand what the long-term game is and how you get the short-term wins. With what we have seen because of COVID-19, this has sort of accelerated that adoption. You know, we see more people and more companies coming to us asking, how do I get on board the digital transformation bandwagon? How do I automate more of my production line? How do I utilize 3D printing to resolve some of my supply chain gluts because of the lockdown? So it's a journey. And I guess, as I mentioned before, for good or for bad, COVID-19 has pushed it even harder. Yeah. People are now more open and they want to be more self-sufficient. And that's the goal. You know, we want to bridge the gap.
Ben, thank you. It's I think fantastic. I think I think we will you know, we will be resilient. We will take charge of whatever the situation, whatever curveball is being thrown at us. And I think with 3D printing, we're going to come out stronger from out of this period for sure. And I think together with NAMIC and AMTC being set up, we'll definitely see a lot more engagement and a lot more adoption. So at this point, I think we're really running out of time. So I'm going to wrap this up quickly. So audience, thank you so much for joining us. I think it's been very valuable, good questions, very engaging, but keep your questions coming to our team at ITAC. And we will be able to answer them as much as possible and connect you via email if necessary. And we hope to see you again at our next engagement session very soon. And from myself, Mahendran from NAMIC, I think it's been a pleasure to be here talking to you and sharing all that. And Ben, thanks for taking the time to be with us. Yeah. So once again, thank you for joining us, and I will see you soon.